Well, good afternoon, everybody. Thanks for the invitation to be one of the speakers today. My name is Nicola Bozzolan, and yeah, I'm researching bioeconomy and climate-smart forestry. Exactly, well, not exactly, but more or less 1 year ago, I was I was discussing successfully defending my PhD thesis at Wageningen University. And today I have been invited to give you a short presentation about my findings on modeling EU forest resources and wood industry demand. So I think it's good that if we go straight a bit into the background, but you already all know this information, but forest sector play a key role in climate change mitigation to its CO2 sequestration and storing capacity. So it's very effective, the CO2 sink from the atmosphere to the wood. And then according to the management of the forest and then the cycle of the forest can face some disturbances. So these fire winds, and then the carbon can be released back into the atmosphere and then and the soil, and then again this cycle goes back. But we can intervene on this cycle by extracting wood from the forest and transform it into wood product, which can be, for example, biomass for production of heat and energy, or, for example, furniture, so storing carbon into the technosphere. Lately, our forests are facing increasing pressure. And this is because, well, as I mentioned before, we are facing a lot of disturbances due to climate change. For example, increasing windstorm, increasing fire, especially in the south, but not only. And the bark beetles infestation, as we have seen the last years in Central Europe. More than that, we have to consider also the EU climate neutrality. So EU and the European Commission set clear goals for the 2050 that we need to be climate neutral. And so forests are fundamentals in this, since they can help in achieving this goal, while also keep reducing the emission from the industries. Least, last but not least, is the EU bioeconomy. So we also need a lot of extraction of wood. So to support the bioeconomy, we need wood for different type of materials for for example, engineering wood product, or for example other type of innovative products that are coming up in the market, and we need a lot of wood resource for that. But so the question is how to combine all these challenges. So how can we provide wood but still leaving enough space to the sink? So we try to answer these questions. We did two research questions. And first of all, we have to understand how are we using harvest wood product and harvest wood resource. And then the second question after this is that, is there a way to improve the use of harvest wood resources? So we explored the first question in a systematic way. We select the 4 EU countries which represent the ecozones through all Europe, and we basically went into the wood chain, and we analyzed the wood chain in detail, creating wood material flows. And we create basically this wood flow to see where the wood is coming and where the wood is going in the chain. As you can see here on the images on the right, you see a lot of line, and I'm not expecting that you pick all the information that are condensed here, but yet I want you to focus on the color. So the green is the raw material, and the red on the right side is the wood fuel, the fuel wood, which goes directly to bioenergy. And then the orange is what is going as a semi-finished product, and then the yellow is the recovered foods. So we translate these food flows into Python script to conduct further analysis, and we included, of course, data from input, export, and residues, together with the waste food and recycled food. But we come up with a publication, and here I present some findings regarding this publication. So what we understood from this paper from 2023. Well, we understood that the food chain are extremely complex and difficult to represent in a model. We found that in these 4 countries that we analyzed, still 50% or more or less 50% of the wood use is directly going to energy, although there are differences between the case studies. Also, we found out that some countries, like for example, Germany, have a sawmill industry with higher processing efficiencies than others. And finally, another interesting fact is that countries with limited wood resources have higher use of byproduct and recovered wood. So then, after this, once we understood the flow of the wood or resources, we then ask ourselves, why countries have this wood consumption pattern? So if you look here again on the right side, this is the wood material flow from the publication Bozzolan et al. 2023. And on the right side, you see this big stream of bioenergy going straight to household and to bioenergy. And so we were asking ourselves, is there a reason, a reason behind this? Like, is connected with the quality, is connected with the tree species? Can we explain this pattern through looking to the wood resource type? And so we dive into this research question. However, doing this approach at European level is not easy. So we had the help of many different models. And this is the method of research question number 2. So looking at the alignment between wood resources and wood demand. For the regional wood supply, we use LMSP, which is a model based on NFIs, which has a really high spatial explicit resolution and can track and can show us the volume of assortment which are harvested per species and the pH classes per year. And here in these images on the left, there is a small representation of the volume per species across Europe. Now, thanks to the model, we know where the wood resources are or the potential harvest could be in the near future and in the long run. But then we missed the demand. So part of my research was to collect the first and create the first European forest industry database. This database is quite innovative because in Europe we do not have per se a database regarding forest industry. And so for this, I collect all this information and I classify the wood industry, the primary processing industries in this database. And it's around 4,000 facilities divided in three main streams: the pulp and paper in white dot, and the bioenergy in red, and the green, the sawmill. Location and capacity are also recorded. So at this point, the modeling framework you present in this slide, and let's take a look at the picture here on the left with the dots. So the model is quite easy. So at this point, we know where the potential harvest is and when it's coming, and is basically represented by this dot, which is the plot where the harvest is taking place. And then in the white dot, you can see like a sawmill, and this is of course an example, but to show what is the framework behind. So at a certain point in time, we have an harvest that is then a harvest wood that is then transported to the sawmill. This harvest is then classified according to the grading system that is shown here on the right side of the table. That say, for example, Norway spruce that is smaller than 10 centimeters, then can be classified as energy. Or Norway spruce that is bigger than 20 centimeters, then can be classified as soundwood. So according to this grading system, according to the potential harvest across the region, we can then allocate the wood resource to the potential primary processes industry. And we did this, and this basically, I also report here an example for the Netherlands, where in the dots here you see the plots, the forest plots, and we connect the potential harvest given this time with the sawmill. And this is what it looks like when we connect the dots to the sawmill for the soft log, for the hardwood, and for the pulp and paper. So this analysis ended up in a publication, and here I report it for you for your convenience. And we analyzed in this publication 3 countries, so Germany, Czech Republic, and Norway. We analyzed we found out that wood resources are generally used in an efficient way, and only limited improvement seems possible within the current processing chain. So wood supply closely aligned with the industry capacity. And what does it mean this? It means that basically most of the sawlogs, or the sawlogs that has been classified as the trees that have been classified as sawlogs are processed by the sawmill. And most of the pulpwood is used to pulp mills or to wood-based panel, and so on. And most of the fuel wood is allocated to the to fuel wood. This is likely because the markets self-balance and allocating higher quality wood to the highest paying buyers. And this is basically also one of the results of this research. Another interesting outcomes of this research that we observe a shortage of softwood and a surplus of hardwood, particularly in Germany. And so that's basically the result of our second research question. I also reported here like a small example of the potential of these results. Is basically this is Norway. This on the left side you see the mills and the connection between the forest plot where the harvest is happening and the mills. And as you can see in the south, you see quite a lot of pressure on the wood resource due to higher presence of wood industry. While in the north, especially in the middle, you have lower presence of mills, and so lower pressure on the wood resource. And that can be used both ways to find where wood could be more available, or also to select areas in order to preserve them. So coming to the conclusion, wood resources are precious and limited, as we know, and an optimized use of the wood, prioritizing its application first for material and only later for bioenergy is highly needed. Increasing the use of waste wood and industrial residues can expand wood resource availability, and this is particularly true for like countries where the wood resources are limited, and so expanding really like creating like new solution to recover wood and reap wood and backloop it into the wood chain is essential. And another conclusion I would say from this research is that wood industry should increase the utilization of different wood type, particularly broadleaf species. As we know, forests are undergoing to different difficult times due to climate change. Probably in the future we will see more broadleaves into the forest, so mixed forest instead of monoculture of spruce. So it's important that also wood industry start to adapt the processing line and is adapting to produce wood product based on leaf rather than just conifer. And the final point is that different wood qualities, so the wood industry also should adapt to use different wood qualities, which is not only types. So, for example, not perfectly strained logs, or for the production of alternative wood products, for example, engineered wood product. So this is because in order to expand even more the wood resource, that and reduce the pressures on the forest, on the standing forest. Yeah, so with this conclusion, I think I also conclude my presentation. And yeah, if you wanna follow me for the research updates, or they are coming soon updates, or what I'm doing, what I'm studying, just you can scan the QR code and follow me. Otherwise, if you have any question or further contacts, please feel free to send me a message or to send me an email that is reported here below. Then I leave the floor to the host. Thank you so much for your attention.
Thank you very much, Mr. Bozzolan. We have got a question from participants of conference, and question is, what is your view on the mobilization of wood resources in Europe? Is the Green Deal not a disruptive factor in it?
So I think like we can always improve wood mobilization, and especially in countries where there's still like potential wood that can be harvested. Many countries, some countries in Europe are still like they harvest less than that they could. So, and some of them are over harvesting. So it's good to find a balance. So that's why I would like to insist on this key message that I want to transmit, that it's not the point. So to achieve this climate neutrality, we should really focus on increasing the way of how we use wood, rather than like harvesting more. Because indeed, like many, while following that the output of this research, we really found out that still like there is a lot of cubic meters that ended up directly in energy on biomass, and that it's actually good food that could be repurposed for something else.
Yeah, okay, thanks. Thank you for the answer. And thank you for joining us today. And yeah, we wish the very best.
Thank you so much.
Thanks.